Hello everyone. In this video, we shall see the projectile motion from an elevated platform, right? I'm opening the phet simulation in which you can see the projectile at a particular angle 80. I'm trying to raise this to a height now. We can actually lift it up to a raised platform. Let me take to the height of 7 meters and let me make it as 60 degrees of projectile. Now let's see how to solve this kind of problems. When I shoot this, this is going beyond. Let me zoom it out. This is where it landed on the ground, and this is where you can figure out the time taken, range, and the total height. All right. And also we can find out the height at the maximum height as well. And also the time taken to reach that maximum height. So let us prove that the time taken to reach the maximum as 1.59 seconds and the height as 19.38. All right. So for doing this, let us first understand at maximum height what component becomes zero. So when you take a projectile, the horizontal component always remains constant, while the vertical component keeps decreasing as it rises up, and here it becomes zero and again gradually increases. So we will make use of this at maximum height exactly. The vertical component of the velocity is becoming zero. But initially it has the component which is u sine theta. All right. The height is h. So, and you know a is equal to g. So we can use the formula v squared minus u squared is equal to 2as. Now vy squared minus uy squared is equal to minus 2gh. This component is 0 minus uy squared minus 2gh. Minus minus gets cancelled. Therefore, u sine theta whole squared by 2g is the height. This can be taken as a proof to show that the maximum height reached with the projectile as u squared sine squared theta by 2g. All right. So now let us figure out the maximum height reached by the projectile. So u is 18 squared and the sine squared 60 over 2 times 9.8. So if you substitute 18 times sine squared 60 or 2 by 9.8 in the calculator, let's see what would we get. Sine 60 times sine 60. So 243 divided by 19.6. You will get 12.39. 12.39 is the height from where it has, this is basically not height, this is vertical displacement. So the vertical displacement from here to here, that means where I have projected the body from here, it's not from zero. So from here to here, I found the vertical displacement as 12.39. But this particular cannon is already at a height of 7 meters. So I have to add this. So 12.39 meters plus 7.00, it would be 19.39 meters. Look at this. Vertical height is 19.38 approximately. Yeah, this is how we find out the vertical height. Here we need to be careful what is h here. It's not the complete height. This is from the point where it has projected. So it is already at a height of 7 meters. Then we need to add that to find out the maximum height or the total height. So 19.39 is proved. Now let us see the another important thing is time, right? So in order to find out time, again we use the same thing, which is at the particular maximum height, the final velocity is 0. And we can use V is equal to U plus AT formula. Vy is equal to Uy plus Ayt. Vy is equal to Uy minus Gt. Yes. So here the final velocity is 0. This is U sine theta minus Gt. Therefore, Gt is equal to U sine theta. And you may write as U sine theta by G. This is the proof for the time taken for the projectile to reach the maximum height. Now the initial velocity is 18 again, sine 60 degrees over 9.8. So if you solve 18 times sine 60 by 9.8, you would get 1.59 seconds. See, 1.59 seconds is proved here. Okay. Now let us try to understand what is the total time taken by this projectile to reach the ground. That means all the way from here to here. So it is 3.59 seconds and the range is 32.19 meters. Let us try to find out this. So for this to find out, we will be taking the vertical displacement as uyt minus half gt squared. Now vertical displacement is the change in the position. So at this particular scenario, the total displacement in the y direction is not 0. From here to here, in the earlier case, from here to here, you can say the vertical displacement is 0. But the object is projected from here to here. Now the vertical displacement is not 0, right? The displacement is defined as change in the position, where it finally landed on the ground, 0, minus where it started from the elevation of 7. So the vertical displacement is 0 minus 7. This is very important. Now uy is u sine theta times t minus 1 by 2 gt squared. Negative 7, initial velocity is 18 and sine 60 degrees times t minus 1 by 2 times 9.8, 4.9 t squared. Now when you write this as equation, you will get 4.9 t square minus 18 sine 60 would be 15.58 times t minus 7 is equal to 0. If you use this equation solver, you will get the time, one negative value, one positive, and we will be taking only positive value for time, that is 3.578 seconds. So if you round it off, 3.58 seconds, which is exactly shown here in the simulation, 3.58. Now let us find out range. Range is nothing but the horizontal displacement. Yes, the horizontal displacement is nothing but x. X is equal to u x times t plus half ax t squared, but ax is 0. Now ux is u cos theta times t. Here t is the total time taken to reach the ground, which is already proved that 3.58 seconds we can use here. And the initial velocity is 18 cos 60 times 3.58. If you use calculator, 18 times cos 60 times 3.58, we get the range as 32.19 meters. So this is the horizontal range proved from this equation. All right. Thank you.